Hi folks, welcome back. So in the previous set of videos, we focused about introduction to GKE Enterprise, which is basically an Anthos, and then different kind of implementation within Google Cloud and outside Google Cloud, and then attaching the different kind of Kubernetes clusters and all those things which we have already done, both theoretically as well as practically with live demonstrations. So now, when we were discussing about Anthos introduction, we touched based on the couple of usages of or the couple of features of Anthos, which are like Anthos service mesh and then Anthos config manager and all. So out of which in this set of tutorials, or in the set of videos, we'll be focusing on Anthos service mesh, which is popularly now called as cloud service mesh. So before trying to understand what is Anthos service mesh and all, it is very much necessary to have the basic knowledge of what is this service mesh and why do we need this service mesh? What are the features of this service mesh and all? So in order to explain those stuffs, I have come up with a simple set of slide which will give the touch base of service mesh architecture and its usage and all. So once we get this fundamentals about service mesh, we will start focusing about the cloud service mesh in detail. So let's start with understanding of this term service mesh. So it's in this slide you can see a simple architecture diagram for service mesh. A typical service mesh consisting of a control plane and then a data plane. So if you see in this diagram, we have three microservice. So for a time being, you just ignore this sidecar proxy container in each of these microservice. So if you remove this, you will be left with just three, plain microservice inside. I mean, basically these are Kubernetes parts technically, inside which you will be running a Kubernetes. A Docker container. So now let's assume you have three different set of application. So if you take a simple shopping portal, you will have a page of entering the user details and then a login page and then you have a payment page. Just an example. So when you divide these into individual service, a typical microservice architecture, so these are different, service altogether. Now, let's see. Let's assume that service A, this container A wants to talk to container B, and container B wants to talk to container C, and similarly container A wants to talk to container C. So when a developer develop these applications, then he has to give the logic for this application, whatever the functionality. So on top of that logic, he has to put an additional logic, which is beyond the business logic. These logics are like the network logic, basically, where he has to whitelist all the endpoint URLs for service B and service C in order for container A to connect to container B and connector to container C. Similarly, if container B has to connect to container A and container C, developer has to put an additional logic for this network connectivity. And then the security wise, like up to what extent this service container A can connect to connector B, how security is, different protocols. I mean, these are like the additional overhead for a developer. Basically, he don't want to do that, and he should not do that as well, because this is just an additional overhead rather than focusing on the business logic. He will be, simply, is like thinking about something else, and on top of that, it's not just about thinking about those logic. If you start putting the individual microservice with these many things. Whenever you want to introduce the fourth microservice, in this case, whenever I want to introduce the the container D, now again, if the container A has to connect to container D, means A has to whitelist the D URL. Similarly, D has to whitelist the A URL. Similarly, B and C as well, has to whitelist the A URL. Something like that. It's just like an additional overhead. So by considering all these overheads, now how service mesh is solving this problem. So what service mesh does is it just puts an sidecar proxy, which is technically a Kubernetes container, one more container which is running on this pod itself, that takes care of all these additional overhead whatever I'm talking about, so that a developer can focus only on his code. All these additional thing about separate logic which he has to put for maintaining the traffic, network security, all those things, everything, this single container, which is sidecar proxy container, will take care, so that a developer can focus only on the application or business logic. So that is what a typical service mesh architecture looks like. So it's its own control plane and data plane. Let's go to next slide. So here is a simple demonstration of how a particular microservice looks like with service mesh and without service mesh. So let's focus on the left side here. If you see this, this is this particular microservice, a developer on top of whatever he has written the logic for application, he has to maintain the communication logic, security logic, observability and monitoring, all those things he has to separately write, and then he has to put it inside this same microservice, which is really a big headache. And it's beyond his maintain he's he or she, whomever, it's beyond their maintenance, because the developers has to focus mainly on the business logic, and these kind of overhead is definitely not required for them. So now with the help of service mesh, what service mesh bringing into the table is, it just brings a separate layer. Okay, like separating your application layer, it totally brings a separate layer which is which is made up of your sidecar proxies. So that takes care of all your communication logic, security logic, and observability, or your monitoring logic, basically. So that's the difference, what a typical microservice looks like with service mesh and without service mesh. So these are all, some of the core features of Anthos service mesh. It's like the traffic management between these microservices, how the traffic has to be managed, like which service has to send request to which other service. All these things, will be done in with respect to the traffic management and observability. So now when the service A connects to service B, typically a microservice A connects to typical microservice B. Whenever it connects, uh, so during that communication, what are all the metrics it is giving, the logs, tracing, everything, it will come with the help of the observability feature. And it has the integration with some of the popularly available tools, like this Prometheus, Grafana, Jagger, and all. And then the security between these microservices, service A, service B, service A to service D, or B to D. So the communication has to be completely secure. So that kind of security aspects will be taken care by the service mesh. Authentic, this communication is via mutual TLS. So and also this communication is purely encrypted as well. And also, whenever a service A sends a request to service B, so that how much time or how much it has to wait, service A has to wait until it gets a response from service B. Basically these timeouts and retries, if it doesn't get the response within a particular period of time, can it retry again to get a response? These kind of resilience kind of features as well, which is available as a part of service mesh. And then the policies, whether the service A is authorized to to communicate to service B, whether service A can communicate to service C. These kind of policies as well, you can put it, which comes as a part of this service mesh. So as I was mentioning, these are some of the popular service mesh implementation stuffs. So out of which Istio is a highly popular and widely adopted tool. Whatever the proxy which I was mentioning in a service mesh architecture, so that is NY proxy, which is the default proxy, and it's a very popular and is written in C++, and it is highly optimized. So Istio is widely adopted that, and it's definitely much more popular tool than any other which is mentioned in this list. And Linkerd is also another popular implementation which is implemented in quite a few production environments as well. And then the console, which is HashiCorp product, so that also comes up with service mesh implementation. AWS has its app mesh, and then you have a CNCF backed open service mesh as well, which is also a very lightweight application, which is also slowly gaining popularity. But again, I may repeat, Istio is highly popular and widely adopted service mesh tool. So here is the a simple architecture of Istio. So before I explain the architecture of Istio, we need to understand one thing here. Istio architecture till version 1.5 and later to 1.5 is slightly differed, because prior to 1.5 some of the components like the pilot, say Citadel, Galley, Mixer, and all. Don't worry about these things, which I'm going to touch base. What are these individual components? But prior to 1.5, these components of Pilot, Citadel, Galley, and Mixer uh, were not part of the control plane. It used to operate separately, and now that from 1.5 onwards, these are part of your control plane. So a typical service mesh kind of an architecture applies to Istio as well. It consisting of control plane and data plane. So you can see here it's an example where you have two microservice, service A and service B. The communication between these two is a mesh traffic. We call it as mesh traffic, and this is via proxy. So the journey is like whenever a request comes from the service A to service A sends a signal to request to proxy, and then between these proxies, how it has to connect and where it has to connect, all those things will be controlled by the control plane components. We have separate components for that. That will take care. So now that it's called as a HTOD. So but still I'll explain the individual components what it's contributing here. So which we'll touch base in the next slide. So it will send this request to the service B, which again received by the proxy container which is running on the service B, which then intercept this request whether it is validated as per the policy and everything, and then it sends to service B. Service B will give the response, which again passes through same channel. So this is a typical communication between two microservice. So if you come to the explanation for individual components, I said the control plane consisting of the Istio-D now. It includes the pilot, mixer, Citadel, and Galley. So let's see the key features of this Istio-D, and then we'll understand which component is doing it. I mean, which component is used to do separately earlier. So now one of the key responsibilities of this control plane is service discovery, traffic management, and routing. So this particular feature was handled by a component called pilot prior to 1.5. So it's like within a mesh, it 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 does the service discovery, like tracks within a mesh and their endpoints, like where it has to connect and where it has to route. So that kind of a thing this component does. And then a certificate authority, which is like somebody has to sit at the top, as I said in the feature of service mesh, that the service mesh communication between one microservice to another microservice is completely secure, and it is MTLS. So there should be a somebody to maintain this MTLS, right? So Citadel is a component which is responsible for this service communication securely with this MTLS. So that's the another feature of another responsibility of the control plane right now, which used to be done by Citadel independently earlier. And then you have a component called as mixer, another feature of a typical service mesh, which is like telemetry, metrics and logs and everything, traces and everything. So that is something is done, used to be done by a component called mixer earlier. Now it is part of the control plane. So whatever it is, generated and everything and all. So exporting between these microservice, what are all the traces are coming and all, that's collection and all is done by mixer. So now it's a part of the control plane. So you need to say that it's a part of the Istio D. So another feature is like the configuration management. So it's like, you know, distributing the traffics rules and between one proxy to another proxies. This configuration, how it has to look like, and for everything and all is done by a component called as Galley. Now, again, it's a part of the Istio D. So these are all individual, components which does their role. Now it's all part of the single entity. It's called as Istio D. It's just, it's responsible for maintaining the control plane functionality in general. And you have your data plane here, which consisting of the NY proxies. It runs, it sits as a sidecar container, and the individual services, and then responsible for communicating between two microservice. So that's a simple explanation for Istio architecture. Now that we understood what is this Istio, let's try to understand what is this cloud service mesh. So you know before what I mean basically, what are all the different kind of service mesh offerings which Google is provided. Since we already had two popular service mesh offers, which is like Anthos service mesh and then traffic director. So on top of that, now Google has released back in July 2024, which is like very new, I can say, the component called as a cloud service mesh. When we already have Anthos service mesh and then traffic director, why did Google come up with this cloud service mesh? Let's try to understand all these things, in detail in the upcoming video. Thank you, folks. Please subscribe to my channel and support me. Thank you.